Hello, I'm Jatin Manyani. Welcome to Chapter 4, the Advanced Process Modeling. Let's dive into the world of process modeling and uncover its significance for businesses. Let's talk about the objective of this presentation. Our goal in this presentation is to give you a thorough understanding of BPMN, covering its components, applications, and advantages. By the end of the session, you'll grasp how BPMN fits into enterprise systems, boosting operational excellence and business agility. So, welcome to Chapter 4, where we dive into the basics of business process management. Here we explore business process modeling notation, which is also termed as BPMN. It is a standardized language that helps organizations visualize their workflows. With BPMN, businesses can streamline operations and boost efficiency. Now in this slide, we'll talk about importance of business process modeling. In today's dynamic business landscape, the importance of business process modeling cannot be overstated. It serves as a fundamental tool for modern enterprises, offering a structured approach to comprehend, analyze, and refine business processes. By visually representing workflows, organizations gain valuable insights to identify inefficiencies, streamline operations, and drive continuous improvement. Uh, so we head on to slide number 5. This slide talks about evolution of BPM. The evolution of BPM showcases its continual adaptation to meet the evolving needs of business process management. So starting with its inception in 2004 with BPM 1.0 version, significant strides were made with the introduction of BPM 2.0 in 2011. These iterations brought forth a host of new features, enhancing clarity and expanding BPMN's applicability across various industries and domains. The key features of BPMN are as follows. BPMN's key features have played a crucial role in its widespread adoption and recognition as the standard for business process modeling. With BPMN 2.0, we witnessed the introduction of expanded notation, enhancing expressiveness in process modeling. Moreover, improved support for photography and collaboration diagrams has facilitated clearer representations of complex workflows. Additionally, the enhanced interchange capabilities have allowed for seamless integration with various modeling tools and systems. These features collectively underscore BPMN's significance in driving operational excellence and process efficiencies. Let's now talk about the fundamental elements of BPMN. First, we have tasks, which represent individual activities or work units within a process, such as sending an invoice or reviewing a document. Next, events signify occurrences in a process, including start, intermediate, or endpoints, as well as triggers for activities. Gateways are pivotal in controlling process flow based on conditions and come in various types, including exclusive, inclusive, parallel, and event-based gateways. Finally, flows depict the sequence of activities within a process and include different types like sequence, message, and association flows. Together, these elements form the building blocks for creating comprehensive BPM diagrams. Now we move to slide number 8. Let's explore the various types of BPM diagrams. First, we have process diagrams, which sequence activities within a single process using standard BPM notation, providing a clear visualization of the process flow. Next, collaboration diagrams. They illustrate interactions between multiple participants or pools, showcasing their collaboration towards achieving a common goal and emphasizing communication, and coordination among them. Moving on to choreography diagrams. These capture the interaction order and message exchange between process parties involved, offering a high-level view of coordinated actions without specifying internal behaviors. Finally, we talk about conversation diagrams. They represent message exchange and facilitate communication between participants, enhancing understanding of communication patterns within a process by focusing on the exchange of messages and information among participants. Talk about rework and repetition. And let's have a look at how do we handle such a scenario. Efficient repetition handling. Utilize expanded sub-processes for streamlined management of repetitive tasks. Another thing is simplified modeling. Isolate repetitive segments within a sub-process for clearer process representation. Visual cue for repetition. Mark the sub-process with a loop symbol to indicate repetition until specified conditions are met. Condition specification. This states that use annotations like until response approved to clarify the repetition condition. Clarity ensured, including a decision activity within the sub-process provides clear guidelines for repetition. Now let's study these examples. So in process modeling, expanded sub-processes offer an efficient solution for handling repetition, particularly when compared to XOR gateways. Let's delve into this with an example involving ministerial correspondence. Here, we simplify the model by isolating the repetitive part and replacing it with a sub-process. This sub-process encapsulates the activities within the repetition block to indicate that this sub-process can repeat until a condition is met. We mark it with a loop symbol and specify the condition, such as until response approved. Additionally, including a decision activity as the last step inside the sub-process ensures clarity in determining when to repeat it. There is another critical concept involved in BPMN, which is parallel repetition. In process modeling, parallel repetition allows multiple instances of the same activity to be executed simultaneously. This is particularly useful when tasks need to be performed concurrently, streamlining processes and improving efficiency. Let's look at the benefits mentioned in the slides and the considerations. So the benefits, efficient execution. Tasks are performed concurrently, reducing process duration. Second is streamlined processes. Parallel execution streamlines workflows, enhancing overall efficiency. Considerations are complexity. Handling multiple parallel tasks can increase model complexity. Second one is maintenance. Models may require revisions when the number of parallel instances changes. Now in BPMN, we encounter parallel repetition, which is a crucial concept for scenarios where we need to execute multiple instances of the same activity simultaneously. So let's explore this with an example from procurement processes. Imagine we need quotes from multiple suppliers, evaluated to select the best quote for a purchase order. Using an AND split, we can model tasks in parallel, but this becomes cumbersome with increasing suppliers. Enter the multi-instance activity, a BPMN construct allowing the execution of an activity multiple times concurrently. This feature simplifies handling multiple instances of an activity, especially when dealing with numerous entities or data items simultaneously. We talk about handling events. Handling events in BPMN involves modeling occurrences that happen instantaneously during a process. These events are categorized into three main types, which are start events, intermediate events, and end events. Now let's talk about the message events in detail. So in BPMN, message events serve as essential tools for capturing interactions between processes and external entities. These events come in three main types: start, intermediate, and the end message events. Start message events, represented by an empty envelope symbol. These initiate process instances upon the receipt of a message. They enable processes to respond promptly to external triggers, initiating workflow execution seamlessly. Then come intermediate message events. They denote the receipt or sending of messages during process execution. They replace activities solely focused on message exchange, thereby enhancing process clarity and simplifying representation. Now we talk about end message events. Distinguished by a darkened envelope symbol, mark the conclusion of a process after sending a message. They provide a clear representation of message sending activities, signifying the completion of workflow tasks. In BPMN modeling, specifying the event type is crucial for clarity. Message events offer a refined approach to representing process dynamics, facilitating improved communication and understanding of workflow execution. Temporal events. Temporal events are also termed as timer events. In BPM and timer events are indispensable tools for process modeling, enabling the triggering of process instances based on specific time intervals. These events come in two main types: start and intermediate. The start timer event initiates process instances at predetermined intervals, such as daily or weekly cycles. Meanwhile, the intermediate timer event represents temporal intervals during process execution, allowing for process continuation after a specified time period has elapsed. For instance, in a small claims tribunal process, timer events drive sequential activities like preparation, contact, and callover, ensuring timely execution of tasks to maintain process efficiency. Tokens in BPN diagrams move through events based on temporal occurrences. Unlike activities, events are instantaneous and do not retain tokens, providing a clear representation of time-driven process flow. Now let's apply this knowledge to model the billing process for an internet service provider. Sequential activities triggered by timer events include invoicing, payment notification, and suspension, ensuring smooth and timely execution of billing procedures. Now let's talk about another key concept, that is racing events. In BPM and modeling, racing events occur when two external events compete to determine the continuation of a process. For example, in freight delivery processes, the arrival of a message indicating freight delivery may compete against a timer set for a shipment status inquiry. To capture this race, BPMN utilizes event-based exclusive XOR splits, depicted as gateways with an empty pentagon enclosed in a double-line circle. Unlike data-based XOR splits, which rely on internal decisions, event-based XOR splits depend on external events to determine the process flow. For example, consider the scenario of a restaurant chain submitting a purchase order every Thursday. If no response or an error message is received by Friday afternoon, the purchasing officer is notified, illustrating the use of event-based XOR splits to handle external triggers. Furthermore, event-based gateways play a crucial role in avoiding behavioral anomalies in pool collaborations. Figure 4.11 illustrates how an event-based gateway resolves potential deadlocks in the communication between auctioning services and sellers. When connecting pools via message flows. Careful consideration of the order of connections is essential to prevent deadlocks. Internal decisions of one party must be matched by event-based decisions of the other party to ensure smooth process execution. Now we talk about handling exceptions. In BPMN, handling exceptions is essential to address deviations from the normal course of a process. These exceptions can be categorized into business faults, such as encountering an out-of-stock product, or technology faults like a database crash. When these exceptions occur, they can disrupt the running process, necessitating special handling to resolve the issue and resume normal operations. For example, an order to cash process. If an out of stock product is encountered, the process may need to be paused to reorder the product from a supplier, or in some cases, aborted if the product cannot be supplied within a specified time frame. Internal exceptions. In BPM, internal exceptions refer to an unexpected events or conditions that disrupt the normal flow of a process. Instead of stopping the entire process, handling exceptions involves interrupting the specific activity responsible. Following interruption, a recovery procedure is initiated to restore the process to consistent state and resume execution. If recovery is not possible, the process may be aborted altogether. BPMN offers error events to capture these internal exception scenarios. An end error event within the sub-process interrupts and throws the exception. This exception is then caught by an intermediate catching error event attached to the boundary of the same sub-process. The boundary event triggers the recovery procedure through an outgoing branch known as the exception flow. Let's talk about external exceptions. External exceptions occur due to events happening outside the process during an activity. To capture these exceptions, we attach a catching intermediate message event to the boundary of the activity. When triggered, this event interrupts the activity and sends the token via the exception flow to execute the recovery procedure. Identifying the scope for capturing such events is crucial. For instance, in the order to cash process, handling order cancellation requests is limited to specific tasks like check stock availability. Defining the scope for event reception. For scenarios requiring the inclusion of multiple activities, we encapsulate them into a sub-process and attach the event to the sub-process boundary to capture exceptions across multiple activities. Let's talk about the last concept in this presentation, activity timeouts. Activity timeouts serve as a safety mechanism in processes. Imagine you have a task within a larger process, but it's taking longer than expected. This is where activity timeouts come into play. They represent an interruption triggered by exceeding a predefined time limit for an activity. To implement this, we use an intermediate timer event. This event is like setting a stopwatch for a specific task within the process. If the task isn't completed within the set time, the timer triggers an interruption. Think of it as having a built-in alarm system. When the timer fires before the activity completes, it essentially says, "Hey, this task is taking too long, let's move on." So the timer event acts as a timeout when attached to the boundary of an activity. It ensures that processes stay on track and don't get stuck indefinitely, improving efficiency and preventing delays. By this, we conclude the presentation. Thank you everyone for your attention and engagement throughout. If you have any questions or comments, feel free to share them below. Have a wonderful day.